Welcome back. We are now looking at sections 5.3 and 5.4, and in these sections we are going to see how to graph the trigonometric functions, like the basic functions and then the transformed functions. So functions which have used transforms. Now in the past we have only looked at mainly three types of transformations, like the horizontal shift, or vertical shift, or we have seen the flip over x-axis and then flip over y-axis. So these are the, basically I'm calling them one like flip and vertical and horizontal shift. Here we will look at a little bit more extra transformations, which are the stretch or compress. So basically horizontal stretch and compress, and also vertical stretch and compress. Okay, let's see. The first function we are going to look at is y is equal to sine of t, or f of t is equal to sine of t. Now if we do it our like traditional way, means by making a table of values and then plotting those points and then graphing the function, it will take a long time. So but still, here the first thing I did is make a table of values. So I remember this is like one set of values, these two rows are the second set of values, because there are so many values for the tangent. So I am graphing it. If you notice here, I am starting at 0 and going all through, so I am stopping at 2 pi. So until 0 to 2 pi, all the those famous t values for which we found the terminal points, I'm using all of them and finding the plugging in the values. Okay, so then I plot the function here. We plot for each of those critical values, and we get a sine function like this. So note here, at 0 the value is 0, because sine of 0 is 0, and then at 2 pi the value is 0, and at pi the value is 0. Sine is 0 at 0, pi and 2 pi. If you want to memorize this, like where is sine 0, it's very important to do that. So just if you forgot what is sine of 0, you should be able to immediately figure it out or find it out by doing this. You make a quick like unit circle, just a small axis and then a circle on it, just imagining, I know it's not perfect square, but just imagining it is a perfect circle. But what are the coordinates of this point? It's 1, 0. Everyone should know this, right? And the coordinates of this are 0, 1, and the coordinates of this point are -1, 0, and the coordinates of this one are 0, -1. So now what is this point is referred to as what t value? So remember, t is equal to 0 for this value. For the top one here, t is equal to pi over 2, and for this one t is equal to pi, and this one t is equal to 3 pi over 2, 3 pi over 2. So now if someone asks you what is the sine of 0, well, 0, remember, sine, remember, is the y value. So sine of t is always going to be the y value, and this is on the unit circle. Sine of t is equal to y. Cosine of t will be equal to x. So if someone asks you what is sine of 0, well, the 0, the t 0, t is equal to 0 has the terminal point 1 0. The y coordinate is 0, so sine of 0 is 0, and so on. So we found the values and plotted them. So but you are not expected to do this. You are not expected to write down this table of values and then plot them. You are supposed to know few points and then be able to graph the function. So this is what I would suggest, that you remember where the function is going to be 0 in the interval 0 to 2 pi in one whole circle. Okay, so between one whole circle the value sine will be 0 at 0, pi and 2 pi. Okay, then where is sine equal to 1? Well, sine will be equal to 1 at pi over 2. So at pi over 2, at this tip of the circle, then where will it be pi over 2? Well, in this unit circle it will not be 1 again. Okay, it will not be 1 again, but where is it negative 1? It's negative 1 at 3 pi over 2. So here this will be pi over 2 and this is 3 pi over 2. So at 3 pi over 2, look, it's negative 1, and at pi over 2 it's equal to 1. So if you remember these few values, 1 2 3 4 5 values, you got your graph between 0 and 2 pi. So what about the rest of the graph or rest of the values? Well, we say it is a periodic function. Okay, I'll just explain in a minute, because now it will repeat its shape. So you go, so 2 pi, so notice here from here to here we are taking a distance is a pi. So 0 to pi, then pi to 2 pi, then 2 pi to 3 pi. It will be the same as between 0 and pi. So it is this piece here, and then from 3 pi to 4 pi it will be same as it is in pi to 2 pi, and so on. It keeps going. And same thing on the left side, between negative pi and 0 it will be the same as between pi and 2 pi, and then between negative 2 pi over here somewhere, and then negative pi it will be the same as it is between 0 and pi, so on. So it just repeats. So this is how you are expected to graph the function of sine of t or sine of x or sine of theta, whatever. The key points of the graphs of sine and cosine are the x-intercepts and the maximum and minimum points. So the maximum point will be 1, height will be 1, and the minimum point will be negative 1. That is something to remember. Also note that if we do this sine of t plus 2 pi, so remember what is this? This is a shift to left to 2 pi units. Okay, so notice here, if I move the graph left 2 pi, so it means from here to 2 pi, wherever it is 2 pi. So we are moving the point at 0 over at point 2 negative 2 pi, or you can say we are moving this point at 2 pi to 0. So what will happen? You will get the same graph, because this is similar to the piece between 0 to 2 pi. So the 2 pi doesn't make any difference to the graph, or in other words, you can think of it like this, that if I go, instead of from looking at the graph from 0 to 2 pi, if I look at the graph from 2 pi to 4 pi, it's the same piece. Okay, and then same thing will happen if you go to, instead of starting at 0, you start at 4 pi, you will get the same graph, and so on. And the shape of the graph doesn't change. But if I do a t plus pi, or t plus pi over 2, or t plus pi over 4 or something, then of course there will be a change. But 2 pi, whether I move left or right, this is the right shift 2 pi, this is the right shift, and this is the right shift, and the first ones are the left shifts. Okay, so the graph doesn't change, you get the same graph. Okay, when this happens, we say that it's a periodic function. Okay, it's a periodic function, and we can just say that sine of t plus 2 and pi, n pi, n pi means n can be 1, 2, plus minus 1, 2, 3, 4, and so on, and also it can be 0. So, and the same will be true for the cosine. I haven't drawn the cosine function here, but I will show you. I mean, you can try on your own. So if I show you, the cosine function will be like this. Okay, so this is 1, this is negative 1, and then I have pi here, and let's say 2 pi over here. So this is how you are supposed to graph the sine or the cosine function if needed. So start by putting I would suggest by putting the period. Okay, if you know the period of the function, start by putting the period of the function at like a maximum length that you have on your paper. So for example, over here I can go until here, but a little bit before that I'll put 2 pi. Okay, then half of it will be pi. Now half of the left side will give you pi over 2, and the half from between pi and 2 pi will be 3 pi over 2. Okay. Now the cosine function, it is 0 at pi over 2 and 3 pi over 2. Okay, and it is 1 at where did my 1 go? Okay, this is, let's say, 1, and this is negative 1. Okay, so this will be 1 at 0. At 0 it will be 1, and at 2 pi it will be 1. At pi it will be negative 1. Okay, so notice here that the cosine function gets one negative value in the interval 0 to 2 pi, whereas the sine got 2 negative values. So this one has 1 negative and 2 positive, and then the other sine is 2 negative and 1 positive. So the graph goes like this. The shape is similar to the sine. So you make it go like this. This is a maximum, so it's going to be like that on the other side, and then we come here, and this is the minimum value, so it will go like this, and then it will go like that. So this is the graph of the cosine in the period 0 to 2 pi. If you have to graph more, then of course we should have space over here, and then we should be able to go more to the right side. Okay, so now looking at what does it mean by so we can here now we can practice the graph of sine. But what we have found until here is that these functions are periodic with a period of 2 pi. So what does that mean? Periodic means they repeat, and what is the period? Whatever the period is, after that the graph will be exactly same as you started from 0 to whatever the period was. So now one complete period of sine and cosine functions is 2 pi, okay, which we have just noticed. And since the sine and cosine function Okay, this is like extra statement here, I should have removed it. Okay, the domain of the sine and cosine functions is all real numbers. Can you see that? It's all real numbers. So sine and cosine exist for any number you think of. Okay, any, like it 1259, yes, there will be a value for sine, there will be a value for cosine. You can plug it in your calculator and check. But when you do it, remember there is two types of modes in the calculator, but it's called the degree mode and the other is called the radian. The degree is of course written like this and the radian is written like RAD. Okay, so if you are saying sine of 1259, then it should be in radians, because this is not in degree. So radian and degree, these are the two measures of angles which we will study later in the next section probably. Okay, so the range of sine and cosine functions is -1 to 1. So the maximum value that sine and cosine can have is 1 and the minimum value they can have is -1. So here now we graph the sine function again. So this is what you, so this is I by x is so 0 here, and then I will take like, let's say 2 pi over here because that is the radius, sorry, that is the period, and then half of it will be pi and half of this will be pi over 2 and half of the here will be 3 pi over 2. Okay, so and if you see, and I have like, I can make a negative pi over 2 over here, and then if I have more space, maybe like a negative pi over here, and so on. Okay, so sine is 0 at 0 and pi and 2 pi, and in the same way negative pi, so it's 0 in all these places. So let's see, so 0 over here, 0 here, 0 here, and 0 here. Okay, okay, where is it 1? Well, it is 1 at pi over 2 will be 1. So let me mark my 1 somewhere. Let's say this is 1, then about this is -1. Okay, so it will be 1 at pi over 2. Pi over 2 the value will be here. At 3 pi over 2 the value will be -1, and at negative pi over 2 it will be -1. Okay, so we can now, you don't do this please. Don't do this. This is not the graph of sine. Okay, this will be wrong. This will be marked wrong. You should have it more curved. Okay, so this is the minimum point. Okay, this is the minimum point, so it should go like this from here. Actually, more like this. So notice here, notice here, okay, this, and then like from here, if you notice one thing, if you look at these two pieces, so this is like opening down, right? And the other one is opening up, like the parabolas. Remember opening up parabola and opening down parabola? But these are not parabolas. So you have a opening down, and then this one is opening up. Okay, now if you notice, this is the point where opening down changes to opening up, and similarly we will have a similar point over here. See, this changes. This is from opening down, opening up, or opens up. Okay, so this is the point where the change is happening, so we call it inflection point or point of inflection. So this is called inflection point. Okay, so this is also inflection point, and we might have seen this point in other graphs as well, the graphs of the rational functions, polynomials, not the logs, not the what was that, the exponentials. No, they don't have inflection points, but the polynomials and the rational functions, they do have inflection points. Okay, so anyhow, so this is how you should draw the graph of sine x. So if you want, you can put the points values. This is pi 0, this is 3 pi over 2 comma negative 1, this one is 2 pi 0, and so on. This will be 0 0, this will be negative pi over 2 comma negative 1, and so on. Okay, so you can do that. Sorry, it's my cat. Okay, so graph of cosine x. So here we go. So first, when we do the same thing that we did up there, so I take 2 pi, then half of 2 pi is pi, and half of that will be pi over 2, and over here 3 pi over 2. Okay, so now again 1 over here and negative 1 somewhere here. So now the cosine is 0 at pi over 2 and 3 pi over 2. Okay? And let's say you forgot. What are you going to do immediately? You are going to make a small unit circle, write the points here. Okay, so the cosine of 0 is 1 because cosine is the x value. So at 0 it is 1. Cosine of pi will be negative 1. So at pi it will be over here. And then at 3 pi over 2 it will be 0. At 2 pi it will be again be 1. And if I go on the left side, let's say this is my negative pi over 2. Just hold on. Mishka, what's wrong with you? Out, get out. Get out. Sorry about that. Okay, see, so now we can graph the function. So over here also the point will be, value will be 0. So it's like this. So this is how we can draw the graph of sine. Normally it will be mentioned like how over what interval to graph the function, but if nothing is said like in these problems, you can just go from 0 to 2 pi, that will be enough. Okay, so now graphs of transformations. So the rule for transformations is similar. So this will mean addition, this will mean a shift up to 2 units. Okay, so this means base graph is cosine, and then we are shift up 2 units. That is the transformation used here. So which means the first thing we should do is move the axes 2 units up. Okay. First I will put tick marks. So I'm going to do cosine. So I will graph it from between 0 and 2 pi, and okay. So now I have to move up, so I cannot take a big one. Let's say this is my 1, and this is my 2, and this is my 3. Okay. So move up 2 units means I have to move. So if you want, you can first draw your original cosine, which will be like this. Negative 1 is over here. Oops, my bad. So it will be negative 1 at pi. And it will be 0 at here, and then this is about the original graph. So this is how it would look. But now I have to move everything 2 units up. So this pi over 2 is now over here, and this 3 pi over 2 is over here. So now the graph will be in 1 unit. So this point will go 1, 2. So it will be at 3, not at 4. Okay, remember this is 3. This should be at 3. So where is the 3? Somewhere here. So this is how you. Okay, what about negative cosine? So with the cosine function, 2 pi, and then 3 pi over 2, and then pi over 2 here. Okay, so remember, for the cosine function we go like this. This is 1 and this is negative 1. So remember, we go like this, right? Now what is this? This is a flip over, or reflection over, x-axis. So it will now be like that. And shift down, up, down, you should know. Now next we are going to look at vertical stretch or shrink and amplitude. Okay, vertical stretch or shrink and amplitude. So we look at these two graphs. So this first one is for y is equal to 2 sine x. so 2 sine x. So if you think about the values, where it was if at 0, sine of x is 0, sine of 0 is 0, so you get 0. At pi it is still 0 because sine of pi is 0, sine of 2 pi is 0. Similarly, sine of negative pi is 0, so 0. But what happens at the values where it was 1? So sine was 1 over here, pi over 2. At pi over 2, if you plug in pi over 2 in here, sine of pi over 2 is 1, but then you multiply it by 2 to, so the tip or the maximum point went to 2. So just let me graph the original function sine of x. It was something like this. Would be something like this. Okay, this is the max. Roughly something like this. Okay, but so if you notice what it looks like is happening is that you pick it from here and you stretch, you pull it that way, and in the same way you take this point and pull it this way. So if you notice, we call it a vertical stretch. Okay? So we have, so when vertical stretch happens, the nodes, these are called the nodes which are on the axes. So the point on the x-axis, they stay where they are fixed. Okay, and then the rest of the graph, it looks like, has been pulled up and down both ways. Okay. So this will be called vertical stretch. Now look at the other graph on the right. So this one is okay. So I was using stretch and compress. Well, we are using stretch and shrink. Okay. So if you graph the original one is going to look like this. So notice here, this will be at 1, negative 1. So it should be more like that, but it's okay. I said roughly. Okay, so now it should be, it looks like someone has pushed this graph down, and from this piece like down in the other direction. So height has come shortened. Here the height maximum value, or the distance from the x-axis has increased, of the maximum point has increased, and minimum point also, like it has become higher in value or lower in number. Okay, so now this we call vertical shrink. So when do these happen? Notice whenever your function sine x or cosine x is multiplied by a number, by any number that we call it a, then we can have a shrink or a stretch, and we say the graph gets a vertical shrink by a factor of 1/2 or 1/3 or 2/3 or whatever, and then vertical stretch by a factor of 3, 4, 5, whatever. So notice that it will shrink if a is less than 1, but a is, yeah, actually we say if absolute value of a is less than 1, then we will get a shrink. So the number absolute value of a is called the amplitude. Okay? The absolute, because you can have, as we saw previously, we graphed cosine of negative cosine of x. So what is a here? A is -1. So -1 did not give any change in the distance from the x-axis. So the minimum distance is still -1 and the maximum value is still 1. Okay, the -1 didn't change. But if you have a number other than 1 or -1, then we will see a shrink or a stretch. So for now, how will you recognize what is the amplitude? Well, if you have a function, okay, so here the amplitude is 2, here the amplitude is 1/2. If you have y equals -3 cosine x, then the amplitude is not -3. Remember, amplitude will be will always be a positive number. Okay, amplitude is, so you can say amplitude is 3. Okay, so now I think we'll take a break here and do the rest in the next video.